First, we're going to study investment rules. This is from Chapter 8, Net Present Value and Other Investment Criteria. There are three methods you need to know. The first one is the payback rule. Second one is the internal rate of return. The third one is the net present value, NPV rule. And this is the best decision criteria. Now, we're going to skip section 8.3, the average accounting method, and also 8.5, the profitability index or PI ratio. Let's just concentrate on that three rules: net present value, payback period rule, and internal rate of return. We're using those three rules in capital budgeting. When you do a capital budgeting for a project, the process including analysis of the potential cash flows, and capital budgeting are always a long-term decisions involved with large capital expenditures. When you make those decisions, then it's difficult to reverse it. So it is very important in a corporation's strategic decision. And we are going to, looking at the rules, we want the good rules should have the following properties. That rule should take all cash flow into consideration. Also take consideration of time value of money, and also allow the risk adjustment if the cash flow is uncertain. And according to those, a good rule should be used to rank the project from the most favorable to least favorable, and indicate this project should or will not increase the company's value. Now, among all those three rules, the most important and most valuable way is the net present value. It's basically answer the question, how much value is created from undertaking an investment? So the net present value rule, the step one, you need to estimate the expected future cash flows. Step two, you need to estimate the required rate of return for that project at certain risk level. The last step, step three, then you just find the present value of those cash flows and subtract the initial investment. Then you arrive at the net present value. That's the three steps usually in a capital budgeting people will take. The mathematical formula, NPV, is a summation of all present values, the cash flow present value, included cash outflow initially when time equal to 0, and the cash inflow when time from 1 to n. Now, initial cost usually write as cash flow 0. 0 represents now. Usually is a negative number. Then when we're looking at net present value, looking at the second equation here, it should be cash inflow. See that the notation, the summation of the notation, T equal to 1, cash flow 1, cash flow 2, up to n. Those represents cash inflow. What is the present value of that? Then you deduct the initial cash outflow. you minus cost. That is the net value. So if the net value or the net present value is a positive, the rule says you accept this project. When net present value is a positive, that means the project is expected to add value to the company. Therefore, it will increase the wealth of the owners. Net present value is a direct measure of how well this project will meet the goal of increasing shareholders' wealth as a goal of a company. Now let's look at a project with the following cash flows. This is a new project, and I have estimated the following cash flow from year 0, now initial cash outflow, up to year 3. Okay, the book value data. So the cash flow we have here for 0 means initial cash outflow is negative $165,000, the initial investment. Okay. Now, the cash flow 1 is 63120. This is cash flow, but the net income for year 1 is 13620. So then we have year 2 data, year 3 data. Now, the required rate of return for asset of this kind of risk is 12%. Okay. Now let's assuming that the project will be the example for all problem used throughout this class. So we are using those 4 numbers to do the calculation. So let's look at the cash flow here. Here the cash flow, mathematically, we just look at like that, right? You kind of math calculation. But we're going to use 2 ways to do it. One is using spreadsheet, using Excel spreadsheet. And the other one is use the financial calculator, using the CF keys. Now, the capital budgeting project, here is the cash flow as given. Initial cash outflow is $165,000. It's a negative number, means is the capital expenditure. First cash outflow, 63120. Second cash flow, 70,800. The third cash flow, 91080. Now, if you use the financial calculator, you put all these 4 cash flows into the CF key. Here's the consequence you need to put into it. Then you need to enter MPV, the third key, under the cash flow line on the financial calculators. When you first time you punch net present value, it requires you to put into discount rate. Here the interest rate is 12%. Then you enter it and you arrow down. Then you compute for net present value. Now financial calculator will do that for you. The result is 12,627 and 41 cents. So this is use TI financial calculator to do how to do that using the CF keys. So if you have still have some problem as for how to using the cash flow keys, you can check the tutorial at the end of the appendix of this textbook. They give you the key entries, right? Now, since most capital budget problem we are using spreadsheet. This is really spreadsheet is shiny. So I'm going to ask you to also study using spreadsheet keys. In that case, we need to study the formula for net present value. Now, remember in Excel, the NPV function actually is not what we understand as a net present value. It is the function of cash inflows, starting from cash flow 1. So this is pretty important for you to understand. Do not just using NPV function as a net present value. The right way to do it is to look at, now here is the cash flow, cash outflow, cash inflow. Now in Excel, we see that equal to NPV parenthesis D2. Now the D2 is the interest rate, percentage 12%, using 12%. Comma, then you're starting from B5. Here B5 is the cash inflow, the first cash inflow, up to B7. It's not starting from the first one, from the B4. You're starting from B5. And then that is the net present value, actually is a, then you plus CF0. CF0 here is the B3. In other words, you computing NPV from the first cash flow up to last cash flow. Then subtract the initial investment, cash flow 0, then you will get the net present value. Do not starting from the CF0. You're starting from CF1. Now be careful about this. I think there is an Excel spreadsheet example in textbook. You need to go over with that. So in Excel, you literally have to minus the cash outflow from the all cash inflow using this whole formula. Don't forget the minus. But if you're using financial calculator, all right, you're starting from 0, cash flow 0, cash flow 1, cash flow 2, up to cash flow n. But in Excel, you using NPV to calculate cash inflow from CF1 of the present value of those cash inflow. Then you subtract the initial cash outflow. Because it's kind of unique for the Excel formula. Now, the net present value method meets all desirable criteria for use as an investment rule for capital budgeting. It takes consideration of all cash flows. You take consideration of time value money. Using different required rate of return, you can adjust for riskiness of that project. Usually, high risky project, the required rate of return is higher. So you can use calculate different project with net present value, then rank them. You choose the highest net present value, right? That is directly related to increase the value of the firm today. So this is the dominant method. In all capital budgeting, net present value should always apply. Okay? If you have other methods, give you other suggestions, always go with, if there are any conflict, always go with NPV. Now, there is another method quite popular is called a payback period. It basically answers the question, how long does it take to recover the initial cost of a project? So the computation, you have to looking at estimated cash flow first. Then you subtract the future cash flow from the initial cost one by one. And looking at the so-called break-even point. How long will it take you to recover all the initial capital investment? The decision rule basically said that you accept it if the payback period is less than some kind of preset the limit. Let's do one example as we mentioned earlier using the same project. Let's look at how do we calculate the payback period. Now here is the spreadsheet example. Year 0, now -165. Now let's create a third column called accumulated cash flows. So at the beginning, the expenditure is $165,000. At the end of year 1, so year 1, you'll receive 63120. So you deduct this number from the 165,000. You still have 101,880 unrecovered. Now, second year, the end of second year, you deduct 70,800 from the previous balance 101,880. You have 31,080 unrecovered yet. So at the end of second year, you have this balance unrecovered. However, for year 3, the total cash inflow is $91,080, which is much more than the remaining balance. So you don't have to using the whole year to recover it. Let's assuming the cash inflow is evenly distributed, make the assumption, through the year. We only need a fractional year to recover the initial investment. How do we find that? We're using the remaining balance. Here is $31,080 divided by the third year cash flow, $91,080. So it's equal to 0.34. So what is the payback period? What is the payback period? It is 2 year, 2 plus 0.34. So 2.34 years. Now, if the management give a criteria, say that, okay, we'll accept a project no more than 2 years. Now this one, you were rejected because it's 2 years. This one, more than 2 years. If the management say that we are going to accept it, this project, the cutoff period is 2.5, for example. In that case, this one is accepted. Now, the payback period obviously has its advantages. It's easy to understand. It is actually a good measurement for liquidity. Usually, people will want the short payback period. The short, the better. So-called low-hanging goods. You can recover. You can get it done very quick, right? So it's basically biased towards a high liquidity project. It has its obviously disadvantages. You basically, in this method, you ignore all time value of money. And the cutting off point in most cases is an arbitrary cutting off period. The management just decided 2 years, 3 years, right? Now you ignore all cash flows after the cutting off period. Therefore, this method has its bias against long-term project. Long-term project. So, but on the other hand, people are still using payback period, which will give you a good measurement of liquidity. Okay, it's a good measurement of liquidity. So we're using payback period as a measurement for liquidity. Show you how many, but we should not using an exclusive method. Now compared to payback period, the internal rate of return, IRR, is much more important. People are using it, particularly the bankers like using it. It is the most important alternative to net present value, and is widely used in practice. It's based on the estimated cash flow and is independent of interest rate. So what is internal rate of return? By definition, internal rate of return is the discount rate that will make the net present value equal to 0. Okay. So, what is the decision rule? The decision rule says you accept this project if this project's internal rate of return is greater than the required rate of return. The required rate of return, in most cases, as cost of a capital, a company capital. So if your borrowing cost is 10%, this project, using one project, that project has a return 15%, you accept it. But if you borrowing at 10%, which is your required rate of return, this project only give you 8% internal rate of return, you reject it. Mathematically, internal rate of return, if you look at the second equation, IRR is the rate of return which will make all cash flows, cash inflow, cash outflow, equal to 0. Then you have a net present value equal to 0. So the calculation in the old days is a kind of try and error. You put a different interest rate in it to find out how do we find that rate equal to 0. Make the net present value equal to 0. So it's using try and error process. However, we can do this very quick thanks to the financial calculator. You just plug those numbers in your financial calculator as cash flow, then punch the key IRR. Then you compute it. It's due very quick. Now, in our project, for example, you have those cash flows. Initial cash outflow, negative 165. Now, don't forget, and when you enter those cash flow in, you need to clear work. Clear work will be second, and the first key on the last row. Clear work. When you punch clear work, then the all previous registration for the cash flow are gone. Okay, so here you enter the cash flow. Now, after you enter all the cash flows up to this step, punch the key IRR, then compute. Very quick. It's give you the result of 16.1322. Or we round it up, 16.13%. Now, should we accept this project? We know the cost of capital is 12%. So the answer is yes, we should accept this project. Now, this is using our financial calculators. Now, using Excel spreadsheet is also pretty straightforward. Unlike the net present value, this one is straightforward. You're starting with cash flow as you did for the capital budgeting, then use IRR functions. You're using all the range from initial cash outflow to last cash inflow. Then the spreadsheet will calculate it for you. For example, in this spreadsheet, I'm using the star indicator. You need to pay attention to this kind of spreadsheet examples, okay? So here is your cash flow, included B3 is the initial cash outflow. B4, B5, B6 is cash inflows. Excel command is equal sign formula, IRR parenthesis B3 to B6. Hit return. It gives you the rate of return 16.13. Pretty straightforward. You don't need to really try and error here. You do very quick. So what is internal rate of return? Here is the net present value profile. You for that previous cash flow examples, you plug different interest rate in it, discount rate in it. At 16.13, that one crossed to the bar. Anything above that, you have net present value negative, which you will reject. Anything below that is you have positive net present value. As we said, net present value should be positive. You should not losing money in terms of today's dollar. IRR is the discount rate, a cutting off rate, exactly on the spot. Here is a break even. In other words, the net present value equal to 0. People like using internal rate of return, particularly by executives. The intuitive appealing and easy to communicate because we say that this project 16.13, 16.13%. It's easy to understand. You don't have to tell me what the net present value is or what discount rate you use. And sometimes if internal rate of return is high enough, you even don't want to know what the cost of capital is. Well, that project have a 50% rate of return. Wow, that is very high. People understand that's a good project. And it also take consideration of all cash flows and time value money, and also provide some indication for the risk. But on the other hand, the internal rate of return do have some disadvantages compared to net present value. Sometimes it can provide multiple answers. This is a mathematical problem. And sometimes you cannot really rank mutually exclusive project. You take one, not the other, right? And sometimes you assume internal rate of return using the same reinvestment, interim cash flow you received, will invest the same rate. So those are disadvantages. We're not going to spend more time on, because of the time limit, limitation of time. As long as I remember that there is shortcoming for internal rate of return. If internal rate of return gives you a suggestion, prefer project A, but MPV prefer project B, go with MPV. Go with MPV. Right. Now, in our early examples, using the example here, the summary of the criteria. Number one, net present value, we accept it because it's a positive. Payback period, if the criteria is 2 years, then it's a question mark. The internal rate of return is higher than the cost of capital, we accept it. Now let's totally ignore the average accounting return. Not many people using it. So here is, right. Let me just show you one example in internal rate of return you might have some trouble. Is if the cash flow are change sign for more than once. Let's look at one project. The project had initial cash outflow negative 90,000 for 2 years, cash inflow. At the end, the cash outflow is 150. You see the change sign, the cash outflow from negative positive once, from positive to negative in that case. Now, net present value, if we calculate this one, net present value, it is 1,769.54 cents. It is positive, so we should accept it. But on the other hand, it depends on what discount rate we use, right? If the discount rate, we are using discount rate using more than 15%, then when we do the calculation, internal rate of return, it's actually, they all, actually in this case, I'm sorry, in this case, you have two internal rate of return for this non-conventional cash flow. One is 10.11, the other one is 42.66. So if the discount rate 15%, if the internal rate of return is 10%, you will reject it. So it's going to give you conflict. But this is a mathematical problem. You have a second order condition if you see that. You have two roots. One is here, one is here. So you have like a break even, you have like a discount rate, two roots. You have two solutions on that. When you cross the x-axis more than once, there will be more than one return. So this is this project have two internal rate of return because it have a cash flow change sign more than once. People say, what kind of a project like that? Oil drilling is one example. So initially you have huge amount of cash outflow. Then the wheel, if you hit the wheel, hit the oil, you generate a lot of cash flows. After a certain point, the pressure is going down. The company have put additional, more money to the drilling, put some pressure in it. Then your cash outflow. And also, some project like a nuclear generation generators. Initial cash outflow, then for many years cash inflows. Then at the end, you need to clear that nuclear side is a cash outflow. So you have those situations. So as I said, that the rule is pretty simple. If internal rate of return and NPV give you different sign, always go with the internal rate of return. Okay, here is one project, two project here. Project 1, Project B. Internal rate of return for Project A is 19.43. Project B, internal rate of return 22.17. But the net present value for Project A is 64,000. Project B have a lower net present value, 60.74. Which product should you accept? In this case, IRR will prefer Project B. NPV will prefer Project A. The rule of thumb is always go with net present value. Okay. The next slide shows you how that one. Because the size of the cash flow and the timing of the cash flow. So if there is any conflict between these two, always use NPV. Now let's briefly discuss the capital budgeting technique in practice. Most companies consider all investment criteria, including net present value, internal rate of return, payback period, and also other like a profit index, etc. Nothing, just do all the calculations. The net present value and the internal rate of return, IRR, are the most commonly used primarily primary investment criteria. These two rules most widely used. Payback period is a commonly used secondary investment criteria, which basically give you indication of the liquidity. So they all provide some sort of information to use it widely. As a conclusion, all the projects should have passed the test of net present value. We're always using net present value is the final rule among all the criteria. So here is a summary calculation, or net present value is a summary, which is a measure dollar increase in value of the firm, future value of the firm, in terms of dollar. Right? The criteria should be positive. Payback period, it measures liquidities in terms of years. Remember, sometimes it's fractional years, right? For internal rate of return, is take consideration of a company's cost of capital is in percentage terms. It should be higher than the cost of capital. Okay, so one is in dollar, one is in year, the last one is in rate of return. Net present value rule, you accept it when the net present value is high and equal to zero. When it's equal, the rate of return is equal to cost of capital. It has no serious flaws. It's a preferred decision criteria. Internal rate of return is the discount rate that makes net present value equal to zero. So you accept it if internal rate of return is higher than required rate of return. However, there are certain problems with internal rate of return for some cash flow pattern if it's non-conventional or mutually exclusive project. Sometimes you cannot make those comparisons. So the last one, payback periods, give you length of the time until initial investment is recovered. The acceptance criteria usually is a bit below what the cutting off period is. Okay, cutting off the period. So, but since it does not take some consideration of time value money and ignore the long future cash inflows, so this one we're just using a secondary method, provide you certain measurement for its liquidity. All right. Okay. Let's take a break on chapter 8. Next lecture will be on chapter 9 on capital budgeting.